We can determine the number of divisors a number has using its prime factorization, but another important thing we're going to need from this lesson is determining if a number is prime or not. So we have to check divisibility by prime numbers less than a given number to determine if a number is prime or not. So, for example, we can determine if 97 is prime by dividing 97 by prime numbers less than 97. If none of the prime numbers divide 97, then 97 has to be prime. And the reason we don't have to check any of the composite numbers is because if a number is divisible by a composite number, then it's divisible by the prime factors of that composite number. So we only need to check prime factorization. We can check 2, 3, 5, and 7. They don't divide 97. But that's not enough because I need to check that no prime number less than 97 will divide it. Because 7, there are lots of other prime numbers past it. 11, and so on. So if we think, all right, let's say there's a prime number bigger than 7 and that prime number divides 97. Then we know 97 divided by p also divides 97 because of that pairing structure of our factors. Because the prime number has to be at least 11 because that's the next largest prime from 7, then 97 divided by p has to be less than 10 because 11 times 10 is 110 and 11 times 9 is 99. So no prime number 11 or greater can divide 97 because that would mean it had a prime or a factor that's less than 10, and 97 does not. So what this concludes with is if n is composite, then n has a prime factor such that p squared is less than n. So if n is a whole number greater than 1, and n is not divisible by any prime p such that p squared is less than n, then n is prime. So we can try this out with an example. Is 397 composite or prime? So we need to figure out the possible primes so that p squared is less than 397. Those are our possible candidates that will divide 397. So I know that 2 squared is 4, 3 squared is 9, 5 squared is 25, 7 squared is 49, 9 squared is 81, 11 squared is 121, 13 squared is 169, 17 squared is 289, 19 squared is 361, and 23 squared, 23 is the next prime, is 529, and that's greater than 397, so we will not need to check 23. So I can check, does 2 divide 397? No. Does 3 divide 397? It doesn't. And you can use your calculator to do this as well, to divide 397, and if it doesn't give you a whole number result, then we can see that the number doesn't divide it. So 5 doesn't divide, 7 doesn't divide, 9 doesn't divide. None of these numbers will divide 397. So because none of these possible primes divide 397, 397 is prime. Let's try it with 91. So we need to ask ourselves again, what prime numbers squared are less than 91? I could go back to the list I just made, but I know that the largest prime number should be 7 because 11 squared is 121. So the only primes I need to check are 2, 3, 5, and 7. So I would say, all right, does 2 divide 91? Clearly no, because 91 is not even. 3 doesn't divide 91 because 9 plus 1 is 10. 10 is not divisible by 3. 5 doesn't divide 91 because it doesn't end in a 0 or a 5. Now 7, I would need to try. 7 divide 91. I ask myself, okay, I can fit 7 in one time. 7, 21, 3. So 7 times 13 equals 91. So 7 divides 91, and therefore 91 is composite because 7 divides 91.